Hi, this is Perry from Reach It, and this is another draft video for which I've submitted to my video team for them to prepare a professional video. It should be available in the next 30 days or so. And the idea of this video is to teach you everything about resistance, right? So flow equals pressure times resistance, and what we want to do is give you all the understanding about resistance and changing resistance and what does that mean in the fluid dynamics that you have between your spigot and your brush, which has got hydroblade fitted. So enjoy it. I hope it's not too much. And if there is anything that you feel should be added or anything which is confusing, then make a comment below, yeah? Okay, so this video is about resistance. Now, what we know is that flow is a constant and we can change the velocity of the water. What we're trying to do is control what's the velocity of the water outside of the hydroblades, which is a rinse bar jets series on the end of the brush. And so we start with a flow rate. Let's say we start at the spigot with a flow rate of 2 gallons per minute, right? So that's critical. It's the amount of water that the beginning of your system is trying to push through your system, which creates the whole system altogether. If you only have like 0.5 gallons per minute here, you'll never get any result there because there's pressure losses all the way through. So let's say we want to actually alter, what things can we do to change the velocity of the water out of the jets? Well, if you have, the flow rate's going to be a constant, but the velocity's not. So let's say you have 0.5 GPM as your target flow rate, which it is, pardon me. Then if the water's only squirting a short amount of distance, then we would reduce number of jets, right? That would be one way. If we reduce the number of jets, right, we're increasing the resistance. If we increase the resistance, we increase the back pressure behind the resistance, which increases the velocity through the resistance. So you can reduce the number of jets. The other thing we could do is we could have the same number of jets, but reduce the orifice of the jets, yeah? So if you think about it, if I just use this little area here, if we have 3 jets that are this size, and we reduce them to 3 jets that are that size, the flow rate will be a constant through those jets. In this sense, the water will go like this, and in this sense, the water will go like this and then drop with gravity. So by reducing the orifice of the jets, we can increase the velocity through the brush, and depending on how all of the rest of the water delivery system is set up, it won't change the flow rate. Whatever the flow rate you've got there. If you don't have enough flow rate there, then you have to change the resistance elsewhere. So 1 is reduce jets. 2 is reduce orifice. 3, if we look at tube, tube reduces the flow rate a lot and creates a lot of pressure losses through tube. So 3, if we shorten the tube, we reduce the resistance. So these are all to reduce the resistance. If we shorten the tube, we reduce the total cumulative resistance that's in the tube. Then we have our hose. If you have 300 feet of hose, it'll have resistance. If you have 100 feet of hose, it'll have less resistance. So 4 is shorten the hose. Yeah, don't have too much hose. If you've got the hose on a reel, you're making the water go round and round and round. Water wants to go straight. It wants the path of least resistance. You're making it round and round and round and round and round. It's always going straight, hitting a wall, going straight, hitting a wall, going straight, hitting a wall. So get all your hose off a reel. So 5, fully deploy reel hose. That will reduce resistance, yeah? So, pardon me. If you have a DI system, you don't have very much resistance in a DI system, so that's fine. But if you have an RO system, then you have a resistance, in the membrane. That's how we're filtering the water, is using water pressure, sorry. So if you want to reduce the resistance, you can't, well, you could go to a DI system. So if you don't have enough pressure, then you go to a dual DI tank system and you reduce the resistance that way. So 6 is, if you're not boosting the pressure, you can switch to DI. So then you can have RO for low, DI for high. Yeah, that's a way of reducing the resistance. And then 7 is reduce this one here, is reduce the resistance here. Reduce length will reduce the resistance. Now there's another one. If you have, let's say you're going to connect from here to here. If you have barbs, right? A barb, you have a piece of tube here connecting with a piece of tube here, and if you put a barb in there, right, the barb actually goes into those tubes, and now the water can only go through the opening inside the barb. That's resistance. So this will be 8 is remove barbs, yeah, out of your system. Barbs, kinks, fittings, you know, anything which is creating turbulence will increase your resistance and reduce the amount of water you've got at the brush. Oh, so what would you replace this with? You would replace them with push fit. So there goes your tube, right? And a push fit will actually fit over and basically maintain the internal diameter of your fitting. So you'll see us with Rhino flat hose, we've gone to push fits to try and reduce the resistance that's being created in the fittings, right? So that's it. That's how you reduce resistance in your system with the intention of standardizing and understanding that if you want you know, a 12 to 18 inch squirt out of your hydro blade from your constructor brush, then this is the way you're going to achieve that, is by understanding how you've lost your flow rate from resistance, building up an increased back pressure through your water delivery system, and then your final adaptation is, for example, if we've got 4 end jets in here and you disconnect the 4 end jets, yeah, so you disconnect the 4 end jets, then you'll have reduced the number of jets. That's one of the sort of in the field ways of doing it. And then for Hydroblade 2, we have 34 jets in Hydroblade 2, and there'll be, you know, basically a high flow set and a low flow set. Same number of jets, same flow rate, just different velocity. But if you can have a bigger orifice of jet delivering the water, you will get a better cascading effect. You'll get a better clean, a faster clean. It's just a dynamic, right, of what we know. Okay. Faster, better, safer.